This is a typical asynchronous replication scenario with Oracle Exadata. Now the Oracle application and the storage sits inside the Exadata. It does not have to be an Exadata. It can be an Oracle server and the storage that is attached to it, but for the sake of convenience, we'll just show Exadata in this example. So you have a primary data center and DR, disaster recovery, secondary data center. Between those two data centers, we have max performance data guard asynchronous replication. In this scenario, data guard replicates across 1,000 miles. Now, the Oracle database will always have the latest last mile transactions inside the redo logs, the online logs, and the archive files. These transactions are unsafe because when you have a disaster, we have a power failure across the data center. If you have a fire, if you have a flood, and everything goes off, these last transactions have not made it yet to the other side. So we have sometimes 5 seconds, sometimes a minute, sometimes more, of lost data in a case of asynchronous replication. Now, how do we know how much data was lost? We don't. We will have to thoroughly check and try to understand what data was lost. We will have to try to reconcile the data right after a disaster, and that will take us hours and hours and hours of downtime, if not more. Now, when you introduce Axana to this scenario, you introduce the Axana black box. The Axana black box is a hardened, disaster-proof device which has both storage and compute. It has a special purpose, disaster special purpose operating system we call the Phoenix OS inside. Now that black box is connected directly to your Exadata. And will survive any disaster. Now what Oracle does, there is a function within Oracle called redo log multiplexing. Multiplexing means that you save the latest redo logs and archive files in more than one storage target. And we just talked about the black box, which is a storage target. So you add a storage target to the Exadata, and the Exadata now saves all of the transactions both to its regular redo and archive repository, but also to Axana. Now, when you have a disaster and the Exadata, the power, all the hardware, everything that was in the data center is now offline, the black box will still survive because it's a black box and it survives any disaster. Now the black box has a battery inside. It also has its own means of communication. It will detect with the software, the Phoenix OS, it will detect the fact that it has a failure in communication between the data centers. It will detect that it has a failure, is not receiving any more data, and there is a power failure. It will move into the battery power, and it will transmit the data wirelessly to the other side, assuming the WAN is inoperable. Now, if the WAN is operational, then the black box will send everything to the other side. Now, there's a piece of Axana software sitting somewhere, even on a virtual server, in the DR site that talks to the black box and is independent from this setup here. It is completely secure. It is over your own VPN communication, but it talks directly to the black box. Now, the black box will have software to auto-detect the disaster, and it will start transmitting the data to, let's assume we don't have WAN, it will transmit the data to the other side over the cellular network, over a very secure, your own VPN network setup. So replication goes on, everything stops, redo an archive, last mile, several gigs of information, could be quite a lot of data, is dead, but the same data is alive inside the box. The box moves to battery, transmits the data over cellular network or whatever network that is available to it, including WAN, brings the data here, and basically the Oksana software on the other side fills in the gap that was there because you lost your last data. So with your regular replication, you would get up to here, and with Oksana, you will complete the missing transactions and get into 100% recovery because the black box just transmitted the missing data to the other side.